Good morning. During the quarantine, unfortunately, since we're not in the classroom, I can't do the examples I generally take and do and talk about there. But let's do a little example about filtering a signal and what it actually looks like. Let's start with this, right? Let's say we have this piece of music. Now, this software lets us actually look at the spectrum also. So we can go to different parts of the spectrum. And what we're seeing here is the Fourier Transform. It's a DTFT of the signal. It lets us actually change the windowing function that we're using, the size, how many points we're taking in the transform. And it also lets us look at linearly, where the frequencies are spread out linearly, or in a logarithmic value, which more closely usually approximates what we're hearing. So if we went and listened to this now, we can actually see the spectrum change while we're playing the music. And it's nice, right, that we can actually go and see what different parts of the signal actually correspond to in frequency, what parts are high and which parts are low. Now, the software also, of course, lets us filter. So what if we filter this? Let's look at a high pass and a low pass filter. Let's say we're going to do a low pass filter, and actually the software lets us actually draw out what we want our filter to be, or the amplitude response of our filter. So this says we're going to pass everything up to 1000 Hertz, and then everything from 1000 Hertz on is going to be attenuated, in this case by 50 dB. So let's press OK. It's going to process it, and we can see that after 1000 Hertz, our signal is lower than it was before. Of course, we can listen to it and actually see what happened. So just leaving the low frequencies removes most of the musical content in this case. Now, what if we went the other way? What if we filtered the signal, but in this case, let's leave the high frequencies and cut out everything below 1000 Hertz. So we're going to attenuate the low frequencies, and we're going to pass the high frequencies. Let's see how that sounds. And again, we can actually see that the low frequencies are now attenuated compared to what they were before. So again, we can see the effects, we can hear the effects that these filters have on our signals. And these are the filters that we're going to be designing.